So this is a continuation of a previous class, that is class number 4.4. And in the previous class, we have started with the second problem on the cam and follower. And we completed this part, that is a displacement diagram for both outstroke angle and the return stroke angle. Quickly, I'll revise this up to this displacement diagram, and I'll continue with this cam profile. So please let me know whether this presentation is visible completely.
Yes, sir.
Okay. So this was the problem in which the type of follower was given as a knife edge follower, and the cam is rotating in a clockwise direction, and they are given four angles. The outstroke angle is 120, which is with a simple harmonic motion, and the first dwell angle is a 60 degree, and after that the return stroke angle is 90 degree with uniform acceleration and retardation motion, and the second dwell angle is the remaining period. It means 360 minus summation of all these things. So you'll get 90 degree. So the total four angles are 120, 60, 90, and one more angle is 90. And it is given the cam is rotating in a clockwise direction from 0 to 360, and the follower will travel through a distance of 3 centimeters. It is given here. The follower to move outward through 3 centimeters. So it is given. And for this, you have to draw a cam profile when the follower axis is passing through the cam axis. So you can see this is nothing but the radial follower, in which the follower axis is passing through the center or the axis of the cam. So both the axes are collinear. And you have to draw one more cam profile when the follower axis is offset to the right by 1 centimeter. Okay, I'll explain while solving this cam profile. So before that, we also found the maximum velocity and acceleration of the follower during outward and return stroke. I'll explain quickly that one. And these are the given things. The base circle radius is given as a 3 centimeter. So in the problem, sometimes they'll mention this as a minimum radius. The minimum radius is nothing but you can take it as a base circle radius, that is capital R, which is equal to 3 centimeter. The speed of the camshaft is n is equal to 1200 rpm. The stroke length of the follower, the maximum distance that is traveled by the follower is given as 3 centimeter. And these are the four angles. First, theta naught, the outstroke angle, 120 with simple harmonic motion. Theta d1, that is the first dwell angle, 60 degree. And the return stroke angle, that is theta r, that is given as 90 degree with a uniform acceleration and a retardation motion. And for the next 90 degree, there is a second dwell, that is nothing but theta d2. These are the four angles which are given in the problem. And based on that, you can choose these formula. For the outstroke, so which is with a simple harmonic motion, I'll select these two formula to calculate the maximum velocity and maximum acceleration. And similarly, the return stroke is with uniform acceleration and retardation motion. So to calculate the maximum velocity and maximum acceleration during return stroke, I'll take these two formula. I'll take these two formulas. Yeah. So these are the four formulas which are required to find the maximum velocity and maximum acceleration. So directly you can use those formula. So first, I can calculate the maximum velocity during outstroke, that is V naught max, using this formula. So I have taken this from a list of formula. So for this, you need this omega. The S is given, that is a stroke length. The theta naught is given. You need to calculate this omega. So you can, using this formula, you can find this omega as 125.664. So after substituting all these values, you'll get the V naught max as 2.8274 meter per second. And one more thing is the angle should be in the radians. The outstroke angle is 120. So To convert into radian, you just multiply with pi by 180. Similarly, using this formula, so you can calculate the maximum acceleration during outstroke. O means outstroke. So for that, you'll get a 532.96 meter per second square. And during the return stroke, again I'll use the formula from the list of formulae. So instead of theta naught, it will be theta r with respect to the return stroke with the uniform acceleration and retardation motion. So already you know this omega, just substitute that value. So you'll get the answer as 4.8 meter per second. That is maximum velocity during return stroke. And similarly, you'll get the maximum acceleration during return stroke as 768 meter per second square. So these are the simple calculation. You can go through the notes which has been shared in the Google Classroom. After this, we have to draw this displacement diagram. Okay, so this is the displacement diagram. So for the outstroke, dwell, return stroke, and the one more dwell. And you can see along the x-axis, I'm taking the angles. The outstroke angle, that is 120. First dwell angle, that is a 60. Return stroke angle, that is 90, and the second dwell angle. Along the x-axis, I'm plotting the angular displacement of the cam from 0 to 360. Along y-axis, I'm taking the distance traveled by the follower from 0 to 3 centimeter. So I'll explain this with the help of the animated slides in the next slides. So after that, after drawing this displacement diagram, you need to draw this cam profile. For the first one, radial follower. Radial follower means you can go through the notes in which I have said that the axis of the follower and axis of this cam is the same. Both are in the same line. And for these four angles, I have to draw this cam profile. And for the second condition, that is for offset follower, it means whenever the axis of the follower is offset either towards right or left. But in this case, it is given as the follower is offset by 1 centimeter towards right. It means there is a gap between the axis of the cam and the axis of the follower. There is some distance. Both are not same. Both are not collinear. Again, the method is same. You have to draw this cam profile. So today we'll discuss about the procedure or the steps which are used to draw these cam profile. And quickly I'll go through the displacement diagram so that if any doubts I can clarify. So this is the scale. You can fix the scale for every problems. Along the x-axis I can take 1 centimeter as a 20 degree, and along the y-axis 1 centimeter as a 1 centimeter stroke length. So along the x-axis I need to plot, just wait for a second. Along the x-axis I need to plot total 360. 360 by 20 is 18 centimeter. I'll take 18 centimeter. I'll draw 18 centimeter along x-axis. And along y-axis, the stroke length, the maximum stroke length is 3 centimeter. So I'll plot this 3 centimeter, and I'll get a box. I'll get a rectangular box. After that, I'll indicate all the four angles starting from the first, the outstroke angle. So it is 120. So the outstroke angle is 120. 120 means 120 by 20. So I'll get 6 centimeter. It will be because 1 centimeter is equal to 20. 2 centimeter 40. 3 60. So for 6 centimeter it will be 120. And the first dwell angle is 60. It means 60 by 20. You'll get 3 centimeter. First centimeter is 20. Second centimeter 40. Again the third centimeter will be 60. And the next angle is the return stroke angle, which is nothing but 90. 90 by 20 you'll get 4.5 centimeter. And the second dwell angle is again 90. So again you just indicate 4.5. So just do the summation, 6 plus 3 plus 4.5 plus 4.5. Total will be 18 centimeter. It means 360. Total 360 degree. So after indicating all these four angles, first I'll divide this outstroke angle with 6 equal parts. So the length of this outstroke angle is 6 centimeters. I want 6 equal parts. 6 divided by 6. So each division will be 1 centimeter like this. So I got these 6 equal parts. I'll give the naming 0, 1, 2, 3, 4, 5, 6. After that, in the similar manner, I will divide this written stroke into 6 equal parts. The total length of this written stroke is 4.5. I want 6 equal parts. It means 4.5 divided by 6. So each division will be 0.75. Since in this case the follower will be coming down, so I'll give the naming in a reverse order. That is 6, 5, 4, 3, 2, 1, 0. So after this, I need to draw the displacement diagram for this outstroke as well as for return stroke. Since the outstroke is with a simple harmonic motion, I'll use the semicircle method only for this outstroke. Because the return stroke is with the uniform acceleration and the retardation motion. There is a separate method for this and there is a separate method for this. And in the first problem, we have discussed what is that method which is used for a simple harmonic motion. So what I will do, I'll use a semicircle method. So I'll take the center of this outstroke. The total is 3 centimeters. I'll take the center point, that is 1.5 from this reference line. I'll draw a semicircle using the compass. Just take the radius as 3 centimeters. Just draw a semicircle. After that, using the protractor, just keep the protractor here and divide this semicircle into 6 equal parts. The total is 180. So I want 6 equal parts. 180 by 6 is 30 degree. So just divide this semicircle into 6 equal parts such a way that each division will be 30 degree. So that I'll get total 180. Just give the namings. It is A, B, C, D, E, F. And from these points, from these 6 points of the semicircle, just draw the horizontal lines towards right direction like this. And these horizontal lines will intersect the vertical lines at 6 points. You can see the intersection points 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash. Okay, whatever the lines that is starting from the first horizontal line and the first vertical line, the intersection point will be this 1 dash, second horizontal line, and second vertical line, it will be 2 dash. Similarly, you'll get 6 equal points. After that, just draw a freehand curve which has to pass through all these 6 points. So this is nothing but the rising of the follower. The follower is moving in a outward direction. Yeah. So this is a displacement diagram when the follower is moving in a upward direction. So you can see the curve is moving or it is rising up. It means you're plotting the distance traveled. For example, it is traveling 0.5 centimeter for first, can say 20 degree. And for the next 20, again it is moving by 0.5. Total is 3 centimeter. So after that, there is a dwell. Well, for the next 60 degree of cam rotation, there is no movement of the follower. So I'll get the curve as a flat. You can see the curve is flat. And I'll go with this written stroke angle, and I'll confirm whether this whether this is with a uniform velocity or simple harmonic or uniform acceleration and retardation motion or cycloidal. There will be 4 type of motions for your syllabus. So it is given in the problem. The written stroke is with uniform acceleration and retardation motion. For that, what I'll do, I'll take this center line. It means the third vertical line. So it is having the height of 3 centimeter. I'll divide this center line into 6 equal parts. That is a 0.5, 0.5, 0.5, 0.5. I'll give the naming as A, B, C, D, E, F. Since the curve has to come down because the follower is returning to its original position, I'll draw a diagonal passing through this center. That is point C, like this. Because the curve is coming down. Then after that, from this reference point, I'll join a line towards point E and point D, like this. Again, I'll take this as a reference point, that is the right bottommost corner, and I'll draw one more line that will join point A and point B. This is the standard method, just remember. Okay, this is the method, this method is standard. And after that, you can see the first inclined line, it will intersect the fifth line at point 5. Before that, So I'll take this as a continuation. So this is the 6 dash. Since the follower is coming down, I'll give the naming in a reverse order. So this is the sixth vertical line. The first, this will be a 6 dash. You can see this will be 6 dash, and you can see the first inclined line will intersect the fifth line at this point. The intersection point will be 5 dash. In similar manner, the second inclined line, it will intersect the fourth vertical line. At this point, it will be 4 dash. And you can take this as a 3 dash. Similarly, the 2 dash, 1 dash. Okay. So you're coming down. It means just take the first inclined line, second inclined, third, fourth, fifth, and sixth. So in a similar manner, just draw a freehand curve just to pass through all these 6 points. So like this. You can see the follower is coming down. The follower is coming down. And after that, for the next 90 degree, there will not be any motion. It means it is given as dwell. Dwell means the follower will be under rest. It means the curve will be straight line. You can see the curve is again straight line. So up to this, we have discussed in the previous class. And we'll continue with the class after this displacement diagram. We need to draw the cam profile. And remember, this displacement diagram is utilized to draw the cam profile because I want these distances 1 to 1 dash, 2 to 2 dash, 3 to 3 dash, and with respect to the outstroke as well as return stroke. Using the compass, you have to measure these vertical distance between 2 and 2 dash, 3 and 3 dash, similarly 6 to 6 dash. You have to transfer these distances on the cam profile for both outstroke and return stroke. Just remember that. We'll be utilizing this displacement diagram to draw the cam profile. And we'll start with the first one, the first case. Draw the cam profile when the follower axis passes through the cam axis. Follower axis passes through the cam axis. This is nothing but a radial follower. Sometimes instead of mentioning these words, they will directly mention draw the cam profile for radial follower. A radial follower means the axis of the follower and the axis of the cam will be same. They'll come along the same line. Just go through the notes, you'll get what is exactly a radial follower. For the to draw this cam profile, the first step is you have to draw a circle. You have to draw a circle, which is nothing but a base circle. So it is already given in the problem, that is the base circle radius as a 30 mm or a 3 centimeter. It is given as 3 centimeter. Just make it as mm. So it will be 30 mm. Draw a circle. So with a radius of 30 mm, which is nothing but the base circle. After that, just indicate the center of this circle as O and indicate the axis of this base circle. So this will be the axis of the base circle, the vertical axis. And at this point, just indicate point A. This axis will intersect this circle at this point. I'll give the naming as point A and I'll draw the follower. So this is point A, the intersection point. At this point, I'll draw the follower. Because the axis of this follower, you can see this is, and the axis of this base circle, both are same as it is given in the problem. And you can mention the height of this follower as 30 mm. So because the stroke length is given as 3 centimeter, you can give the height of this knife edge follower as 30 mm. Since the type of follower is knife edge, I'll indicate with a conical shape or with a knife edge at this point A. So this is the second step. First one is you have to draw the base circle. After that, you have to draw the knife edge follower in such a way that the follower axis and the axis of this base circle are same. They'll come in the same line. After that, I'll join point O to point A. So you can see the blue color line. I'll take this as a reference line, the first line, or the 0 degree line. Because I'm going to start from this point. This is the initial line, you can say, the reference line. From this, I'll start indicating the four angles, that is 120, 60, 90 and 90. And before that, I'll confirm whether the cam is rotating in a clockwise or in an anti-clockwise direction. In the problem it is mentioned the cam is rotating in a clockwise direction. For that, what I have to do, I have to indicate all the four angles in a opposite direction. It means in a counterclockwise direction. Remember, the cam is rotating in a clockwise, you need to indicate all the four angles in a counterclockwise direction. So if the cam is rotating in counterclockwise, you need to indicate the angles in clockwise, towards right. But in this case, I'll indicate all the angles in a counterclockwise direction. It means towards my left. So for that, first I'll keep the protractor over here in such a way that the 0 degree of the protractor will be in line with this vertical line, that is OA. So this will be a 0 degree line of the protractor, like this. And I'll start indicating the angles. The first angle is the outstroke angle, that is 120. So first I'll indicate the angle 120, that is angle AOB, towards anti-clockwise direction or the counterclockwise direction, like this. Now after that, what is the next angle? The next angle is 60. So you can see. So I'll take the angle BOC as a 60 in a counterclockwise direction. In a counterclockwise direction. Yeah. So this is the second angle, that is angle BOC. After that, the next angle is the return stroke angle, that is the 90 degree. So I'll take this as a reference line. Again, using the protractor, I'll indicate next 90 degree in an anti-clockwise direction. So this is COD in a counterclockwise direction. That is nothing but a return stroke angle, 90 degree. And it is 12 for the remaining angle. The remaining angle will be 360 minus 120 minus 60 minus 90. It will be 90 degree. That is DOC, the second dwell angle. So far I have indicated all the four angles, and I need to concentrate mainly on this outstroke angle, that is AOB, and the return stroke angle, that is COD. So what I'll do, first I'll take this the outstroke angle, that is 120, and I'll divide this circle between point A and point B. With respect to this 120, I'll divide this part of the circle, that is from A to B, only this part, into 6 equal parts. Since the angle between point A and point B is 120, I want 6 equal parts, that is 120 by 6. Okay, it means 20 degree each. 120 by 6, 20 degree each. So I'll divide this circumference of the circle between point A and point B into 6 equal parts. So use the protractor, just indicate the points, 20 degree, 20 degree, 20 degree, 20 degree. You can see you'll get the intersection points. I'll give the namings as 0, 1, 2, 3, 4, 5, 6. I have divided the circumference of the circle at this area, that is between AOB, into 6 equal parts. Each division will be 120. Okay. After dividing this circumference into 6 equal parts, draw the radial lines towards the center of the circle. From each point, that is from 1, 2, 3, 4, 5, 6, draw the radial lines. So these blue color lines are nothing but radial lines. After drawing these radial lines, just extend these radial lines in a backward direction, like this, to some distance, to some convenient distance. After that, I'll go to the displacement diagram, because I need to transfer the distances from this point 1, 2, 3, 4, 5, 6 on these radial lines. I'll go to the displacement diagram. So this is my displacement diagram. Using the compass, I'll copy these distance from 1 to 1 dash, 2 to 2 dash, 3 to 3 dash, up to 6 to 6 dash, only with respect to this outstroke. Just copy these distance one by one with the help of a compass. and go to the cam profile. Okay, and take the reference as point 1. Just cut an arc. So you have copied the distance 1 to 1 dash. Take the reference as 1. Using the compass, just draw one arc like this. So that arc will intersect this first radial line at this point. Just give the naming as 1 dash. Similarly, just copy all the 6 distances, this, 6 vertical distance from the displacement diagram with respect to the outstroke angle. Just copy the distance 2 to 2 dash. Just take the reference. Just draw one more arc. You'll get the intersection between that arc and this radial line at this point. That is nothing but 2 dash. Similarly, you'll get 3 dash, 4 dash, 5 dash, 6 dash with respect to these 6 radial lines. After that, you just draw a freehand curve which has to pass through all these 6 points. You can see the pink color line. So which is nothing but the cam profile for outstroke angle, which is passing through all these 6 points. In a similar manner, just use the same method whatever you have used for this outstroke and do the same thing for this return stroke. The return stroke is 90 degree. The return stroke is 90 degree. Just wait for a second. So I'll divide this area of the circle, the circumference of this circle, so between point C and point D into 6 equal parts. The angle covered is a COD, that is 90. 90 by 6 is 15. Using the protractor, just divide the circumference of this circle into 6 equal parts. Just indicate 6 points. So you can see here, you'll get 6, 5, 4, 3, 2, 1, 0. And each division will be 15, 1, 1, 5, because 90 by 6 is 15. And just draw the radial lines towards the center of the circle from these 6 points. You can see these are the radial lines towards the center of the circle. After drawing these radial lines, just extend these radial lines in a downward direction like this. You can see I'm going to extend these radial lines to some distance. After that, again I have to transfer the distances from the displacement diagram with respect to these 6 points, 6, 5, 4, 3, 2, 1. What I'll do again, I'll go to the displacement diagram over here, and I'll copy the distances. With respect to this return stroke, I'll copy 6 to 6 dash, 5 to 5 dash, up to 1 to 1 dash, one by one. Use the compass, just copy these distances. Yeah, and take the reference as 6, just draw one arc, which will cut this 6th radial line at certain point. Similarly, you'll get 6 intersection points between those arcs and these radial lines. It means you have transferred 6 to 6 dash, 5 to 5 dash, 4 to 4 dash, up to 1 to 1 dash with respect to the displacement diagram of return stroke corresponding to the return stroke angle. After getting all these 6 intersection points, just continue from point 6. So from this 6 dash, just continue the line with a freehand curve and draw a curve which has to pass through all these 6 points. So this is nothing but the cam profile. I have started from this point, so I'll end up to this only. So around this circumference of the circle at this area, just continue the line. You can see. So I have started from this point. Again, I have ended here only. So this was the reference point. So this pink color line indicates the cam profile. So you can see here. So this is the outer surface or the pattern of the cam, how it has to be designed. As for the requirements is the angles, what should be the outstroke angle, return stroke angle, what is the dwell, and what is the distance traveled by the follower. Based on all these inputs, I got this output, that is cam profile. So this completes the cam profile for the first condition, that is for radial follower. Means when the follower is the follower axis is passing through the axis of the camshaft. You can see both the axes are the similar line. After that, you just give the namings. Okay, the base cycle radius is 30 mm, cam profile, the knife edge with a height of 30 mm. So I hope this is clear. If any doubts, please ask. If it is clear, you can say yes. Otherwise, I'll go to the next slide.
Yes, sir, it is clear, sir.
Okay, thank you. And I'll go to the second condition. Just make it as B. The second condition is yeah. So this is your second condition. Again, you have to draw the cam profile. In this case, when the follower axis is offset to the right by 1 centimeter, it means the follower axis is offset to the right by 1 centimeter. This also matters. The offset is towards right or left. Okay. So first, again, I'll start with the base circle with a radius of 30 mm, which is given in the problem. After that, I'll indicate the axis. Before that, I'll draw one more circle. I'll take the reference as the point O. I'll draw one more circle, and the radius of this circle should be 10 mm. So, which is equal to the offset. This will be given in the problem. In the second condition, it is given the follower is offset towards right by 1 centimeter. 1 centimeter is nothing but 10 mm. Just take that as a radius, that is r is equal to 10 mm. So you can see it is given as 1 centimeter. 1 centimeter means 10 mm. With respect to that radius, I'll draw one more circle at the same point. You can see both the circles are having the same center. And after that, I'll indicate the axis of this base circle as well as the offset circle. Okay, so this is the vertical axis of the base circle or the cam. Then what I'll do, I'll draw a horizontal line, a horizontal radial line like this. With respect to the offset circle, just remember these points. I'll draw one radial line or the radius of this offset circle because I want a tangent line to this offset circle like this. Because in this case, I need to indicate the follower in such a way that there should be some gap between the center of the base circle and as well as the axis of the follower. So it is given as the 10 mm because there is a gap. So there's a distance because the follower axis and the cam axis are there away from a small distance, that is the offset. So I'm drawing this tangent towards my right because it is given in the problem the offset is towards right. If it is given in the left, you have to draw the tangent towards your left. That is the only difference. Okay, the remaining will be same. The steps will be same. After that, you can see this follower axis or the tangent to this offset circle. It will intersect the base circle at this point because I need to indicate the follower, which has to be in contact with this base circle. I'll indicate this point as point A. So the intersection between this tangent line and the base circle at this point as point A. At this point, I'll draw the follower. You can see the knife edge follower with a height of 30 mm. With a height of 30 mm. Now you can clarify why I have drawn this tangent because I need to indicate the follower. Before indicating the follower, I want the axis of the follower. Okay, which is offset with respect to the center of this base circle by 10 mm. this distance will be 10 mm. So that's why I have taken the radius of the offset circle as 10 mm. And after this, what I will do after getting this base circle and after getting this follower, I'll join point O and point A like this, because I have to start indicating the angles in a counterclockwise direction. I want some reference line. Always you have to join the center of the base circle and the edge of the this follower, that is point A. In the previous case, the point A was here because that was the radial follower. But in this case, the point A will be towards right. It is offset towards right. It is a slightly moved towards right. Such a way that the distance between those 2 points will be 10 mm. And after that, I'll check the direction of the cam, and it is given that the cam rotation is in clockwise direction. The problem it is mentioned, the cam is rotating in a clockwise direction, so that I need to indicate all the 4 angles in a counterclockwise direction, opposite to this cam rotation. And I'll take point this line OA as a reference line. I'll keep the protractor over here in such a way that the reference line of the protractor, that is the 0 degree of the protractor, will be in line with this OA line, like this. The protractor will be like this, and the center of the protractor will be at this point. And I'll start indicating the angle in a counterclockwise direction, similar to the first case. That is, the first angle is 120. So I'll indicate angle AOB, and I'll write down this point, point B, with respect to the base circle around the periphery or the circumference of this base circle. I'll indicate all these point A, point B. I'll not worry about this offset circle. This offset circle is only used for drawing this position of, or the locating the position of this follower. Yeah. After indicating the first angle, I'll take the line OB as a reference line. I'll indicate one more angle, that is 60. I'll indicate one more angle, 60 in a counterclockwise direction, that is BOC. Again, I'll indicate the alphabet C on the circumference of base circle. And what is the next angle? The next angle is a written stroke angle, that is 90 degree. That is nothing but COD. And the remaining will be DOA, the second dwell angle. So I can show once again. I have taken the reference line as this one. The 0 degree of the protractor has to be in line with this OA line. And I'll start indicating the angles in a counterclockwise direction. The first angle is AOB, that is 120. Second angle is BOC, that is 60. COD, that is 90. And the last angle is 90 degree, DOA. And I'll concentrate mainly on this outstroke angle, that is 120, and one more, that is a written stroke angle. I'll not worry about the dwell angle, that is the first dwell angle and the second dwell angle. First, I'll consider this outstroke angle, that is 120. Again, similar to the first case, I'll divide this circumference or the periphery of the circle between point A and point B, which covers total, that is 120 degree. So I want to divide this circumference at this point, at this area only, between point A and point B, into 6 equal parts. It means 120 by 6, it will be 20 degree. Use the protractor, just indicate the points over the base circle, not on the this offset circle. On this circumference of the base circle between point A and point B, I'll indicate the points with the help of protractor, and each divisions will be 20 degree each. I'll give the namings, that is 0, 1, 2, 3, 4, 5, 6. And in this case, I'll not draw the radial lines towards the center of the circle, because this is not a radial follower. So this is the offset follower. It means, so this is the axis, you can see. This is the axis of the follower, which is tangent to this offset circle. So you can see the axis of the follower is tangent to the offset circle. It means I'll not draw the radial lines. Instead of that, you have to draw the tangent from all these 6 points, because the axis of the follower is tangent to the offset circle. So that's why what I will do, from all these 6 points, you can see here, I'm drawing the tangent lines, not the radial lines. If it is the radial lines, means you have to join point 1 to point O, which was the case of radial follower. That is the first case. But the second case is of offset follower. That's why I'm going to draw a radial lines from all these 6 points with respect to the offset circle with a radius of 10 mm. So only this is the change with respect to the first radial follower and this offset follower. After drawing the tangent lines, or you can say as a tangent only, correct, tangent lines from all these 6 points, I'll extend these lines towards backward direction like this to some convenient distance. Again, go to the displacement diagram. Again, I'll go to the displacement diagram. You can see here, and I'll consider this part, that is a return stroke angle, because I have to draw the cam profile for return stroke, that is for 90 degree. So before that, I have to draw the cam profile for the outstroke. Just make a correction. Before drawing the cam profile for the return stroke, I'll go with this outstroke angle. After completing this, I'll go with this one. And I know the 6 vertical distance, that is 1 to 1 dash, 2 to 2 dash, 3 to 3 dash, up to 6 to 6 dash. With the help of compass, I'll copy all these 6 distances one by one. And again, I'll go to the cam profile. Okay, again, I'll go to the cam profile. So I'll take the reference as 1, 2, 3, 4, 5, 6. First, I'll copy the distance 1 to 1 dash. I'll take the reference as 1. I'll draw one more arc. I'll draw the arc here. And that arc will intersect the first tangent line at this point. Approximately, you can see it. So this is nothing but 1 dash. Similarly, you'll get the remaining points. It means you need to transfer the distance from the displacement diagram with respect to the outstroke angle, not the return stroke. Just make the correction. So I have transferred 2 to 2 dash, 3 to 3 dash, up to 6 to 6 dash. With the help of compass, I have drawn the arcs, and those arcs will intersect these tangent lines, the blue color lines, at 6 points. That is 1 dash, 2 dash, up to 6 dash. After getting all these intersection points, I'll draw a freehand curve, that is a pink color one, which will pass through all these 6 points. So this is nothing but the cam profile for the outstroke angle. This is only for the outstroke, not for the return stroke. The similar manner, I need to draw the cam profile with respect to this return stroke angle, which is nothing but 90 degree. So first I'll divide this area of the base circle between point C and point D into 6 equal parts. That is 90 by 6, 15. Just indicate the divisions, that is 15, 15, 15, 15, 15. Only indicate the points on this area of the base circle. Don't draw any radial lines. Only indicate these divisions, that is a 15, 15, 15, 15, with the help of protractor. And I can give the naming as 6, 5, 4, 3, 2, 1, 0 in the reverse order, because the follower will come down. It will be coming down during these return stroke angle, that is 90 degree. After that, again I'll follow the same method. It means from all these 6 points, that is from 6, 5, 4, 3, 2, 1, 0, I'll draw the tangent lines. I'll draw the tangent lines with respect to the offset circle. You can see here. I'll draw the tangent like this. from this point 5, 4, 3, 2, 1, 0. You can see here. So all these are tangent lines with respect to the offset circle from all these 6 points. After drawing the tangent lines, just extend them in a downward direction to some convenient distance. Okay. After extending, again just go to the displacement diagram. Again go to the displacement diagram. So this is our displacement diagram, and I want the cam profile for return stroke. So you can see here. So already I know the distances, that is 6 to 6 dash up to 1 to 1 dash. I know all these vertical distance. I'll copy this with the help of a compass one by one, and I'll go to the cam profile with respect to this return stroke angle. Again I'll take the reference as a 6. I'll draw the arc, that is you'll get the intersection point, that is 6 dash. Again I'll copy the distance, that is 5 to 5 dash, from the displacement diagram corresponding to the return stroke angle. I'll draw one more arc by taking the reference as 0.5. That arc will intersect this second tangent line at this point. So this is nothing but 5 dash. Similarly, you can transfer all the 6 distances from the displacement diagram, and you'll get these 6 intersection points on these tangent lines. After this, I'll continue this cam profile. So just draw the freehand curve which has to pass through all these 6 points. And I have started from point A, or from point 0. I'll end with this again point 0. So I'll continue this curve over this base circle. So you can see here. So this is the continuation. So this is the complete cam profile for this offset type of follower. So why it is called as an offset? You can see. So there is a distance. There's an offset between the center of the base circle or the cam and the follower axis. They are not the same. Only this is the difference. One more thing is, instead of drawing the radial lines, you need to draw a tangent lines to this offset circle. This is one extra circle which you'll get in this second case, but not in the first case, the radial follower. After that, after getting all these things, you just indicate the cam profile, and this is a base circle with a radius of 30 mm. So this is the offset circle, which is extra for this case, and this is the knife edge with a height of 30 mm. Okay, so this is nothing but the second case. So if any doubts in the first cam profile and the second cam profile, please let me know. So, and I can show the PDF which I have drawn on the plain paper. So this is already there in the Google Classroom. Yeah, so this was the second problem. So these calculations and the displacement diagram. So you can use different colors of pencils or a pen. So draw it neatly so that while doing the revision, you can save the time. It will be convenient for you people. So just indicate all the angles on this displacement diagram. After getting the displacement diagram, so you can draw the cam profile. So this is for a radial follower. So you'll get like this. So this is the exact cam profile. Whatever I explained with the help of slides for all these 4 angles, I got this cam profile, and this is the base circle. You can see all our radial lines towards the center, and you have to indicate the direction of the cam, whether it is in a clockwise or the counterclockwise. For this case, it is clockwise, and you are indicating the angles in a reverse manner: 120, 60, 90, and 90. And this is the cam profile for the offset follower, and you can see all the lines which are started from 0, 1, 2, 3, 4, 5, 6. They are tangent to the offset circle. So this is the one extra circle you will get in the second case. So here you'll get only one circle, that is base circle. But in the second case, you'll get the base circle as well as offset circle, because you need to draw the knife edge in such a way that the follower axis of the knife edge and the center of this base circle, they are away from a small distance. That is nothing but 10 centimeter towards right. You can see the follower is offset towards right. Okay. So this is the completion of this second problem, that is the knife edge follower for both radial follower and the offset follower. So if any doubts, you can ask. Otherwise, I'll wind up today's class. Okay. Thank you.